Hello everyone. On this video, I want to talk a little bit about how to understand w- what it is on this black box of neural network, right? So we are going to try to add more explainability to our neural network. That is a kind of area of study on the artificial neural network. It is the explainability of neural networks because we don't really know what it is happening under the hood during the training process, and therefore it is pretty hard to debug and see what is the reasoning behind the behavior of our models. So to bring a little bit light, bring some light to this black box, we had implemented this live neural network and kind of showing what it is really behaving while we are training our model using evolutionary algorithms, right? So basically, I'm talking about this area here, and this is the representation of our artificial neural network. And you can see here, depending of the inputs and the state of the inputs, this will be generating different, let's say, values of behavior or weights in different layers, and in the end giving us output, which it is to tell to our car to go forward, to the right, to the left, and backward, right? So just let's look at the what you have our code first and see how we are drawing this. And everything starts on our car, let's say, and we pass the layers or the architecture for our neural network, which you can see here: 5 inputs, 6 and 4 hidden layers, and we expect 4 outputs. And that's what you have here, right? So 5 inputs, then you have 6 and 4, and then 4 again to the output. And the inputs, as we already spoke, it is our sensors of our car, and that's where everything starts. But let's look a little bit on the neural network itself, right? And we can see that basically we build some layers, and let's see what it is our layers look like. So this is our layer, and you can see that inside the layers we have the type of layer that can be input, hidden layer, or output, so different types. We have the activation function, which is the function that will be executed before the output of our layer. And you have weights and you have bias, and you have the input and output stored here. So, and it's basically that's it is our layer properties. And you have a main action, which it is basically perform the feed forward action. And it is basically how under the hood what it is feed forward on a layer level is a matrix multiplication between the input and the output, and then applying some biases and executing the activation function. We talked about this deep in a more deep way on my course about neural network with JavaScript from scratch, right? So again, please go and check it out to get a better understanding of what is happening under the hood when you're talking about neural network. But that's it, basically that. So, and what we are doing, it is basically plotting these informations here. See the weights and the biases of our layer, and which will be like this. And so this will be plotting this, and we are representing the weights as the arrows, right? And we are representing the bias as the circle around each neurons. And let's understand a little bit what is weight, right? Learning occurs as part by the strengthening of connection between neurons. So this the weights here. It is represent the strength of neurons, right? This is the weight have been represented. With weights input, the network can increase or decrease the strength of the connection between each neuron in this layer and the neurons in the next layer. So basically talking this connection still. Weights are the coefficients of the equation which you are trying to resolve during the training phase. So basically, why you are training, what you are trying to do, it is find the optimal weight for each neuron, right? That is basically what you're trying to achieve when you are talking about be training a model. You're trying to find the optimal weight that will be result on the right output. And as I said, the weights are displayed in arrows between the neurons. The weight strength are displayed as the alpha, right? So if the weight it's small, you'll be very little alpha here, and if it's yellow, it is very strong positively, in a positive way, and then when it's red, it's very strong on a negative value. So basically, positive and negative values can be the output of neurons, or better saying, the weights for the neurons. The same for bias. Let's understand why it's bias first. Why weights enable an artificial neural network to adjust the strength of connections between neurons. We already talked. Bias can be used to make adjustment within the neuron, right? Basically, the addition of bias reduces the variance and therefore introduces flexibility and better generalization in the neural network. So basically making not a not linear equation. So bias, it is one that we use to make more generalized, right? So when you say generalized, it's making, doesn't matter, the training don't need to be the same when you are performing things. So on the example of classification, so you give, if you give an image during the training that it's, let's say, black ball, when you are testing and executing, perform testing the model, you can use a yellow ball and you will still work well because it has some generalization applied. So that's what they mean here. So each input will result different output for each neurons, and that's what we're trying to achieve here. So when you hit here, you can see that it is a very strong, let's see when it stops. So a very strong, this input and input, and this one, and little and nothing for this one was before, and that would imply and say and in this output here, and you can kind of see so how strong each neuron output, right? And you can see the weight, how strong it is, the connection between the neurons in different layers. So in summary here, we are trying to bring some explainability to our black box models, and you can kind of see the behavior as it goes. So this can be a very good tool when you are debugging and trying to understand the behavior of the model during the training step. Okay, I hope that made sense, and I hope you can guys apply this for your own projects. And we have created a separated neural network visualizer that you can use, so you can use that separated any project. So it's part of our library, but you can take only this part and draw any neural network that you have. So basically you just need to pass your neural network, and this would be looking at the layers. Very simple. So this is more related to, I'm not going to go so deep here because this is it shows more the canvas process than the real neural network related, or neuroevolution, that is the subject of this course. So we are just plotting, so you can see here and learn if you are curious how everything is plotted, but in the end of the day, it's just taking architecture and make sure we plot that in a very visual way. That's it. So thank you very much and happy learning.